right, so in this video, we're going to go over the octet rule, which basically states that atoms tend to combine such that each atom has 8 electrons in its outermost shell. So with that, we're going to see a couple of trends. So for example, we'll see that carbon has 4 valence electrons, so it's going to want to form 4 bonds to get 8 valence electrons in its outermost shell. Nitrogen has 5 valence electrons, so it's going to form 3 bonds. Oxygen has 6 valence electrons, so it's going to form 2 bonds. And fluorine and the other halogens have 7 valence electrons, so it's going to only need to form 1 bond to fulfill the octet. This is similar to hydrogen, which violates the octet rule as it only needs 2 electrons to fill its outermost shell. So hydrogen is only going to need 1 bond to have the octet rule fulfilled. So with that, let's practice a couple of these molecules. So let's start with this one. We always start by drawing carbon in the middle, and then we build from there. So we have the CH3, so that means that 3 hydrogens are going to be attached. So hydrogen, hydrogen, hydrogen. And then OH is a functional group that's hydroxyl group. So we're going to attach it over here like that. So that's the quick and dirty way of doing it. However, whenever you just begin starting, you can draw it as such. So you have 4 valence electrons around the carbon. Hydrogen has 1. Hydrogen has 1, hydrogen has 1, oxygen has 1, 2, 3, 4, 5, 6, and hydrogen has 1. And what you can do is you can pair up the electrons, because that's what makes the bond, 2 electrons in every covalent bond. And then oxygen has 2 lone pairs left over. So this and this molecule are essentially the same. All right, so with the second one, we're going to encounter a double bond. So let's start by doing it this way first. So we'll have the carbon, which has 1, 2, 3, 4 valence electrons, which you can always tell from the periodic table. You have hydrogen with 1, you have hydrogen with 1, and then you have oxygen with 1, 2, 3, 4, 5, 6. Notice how where I draw the double on these oxygens doesn't really matter. These are just Lewis structures. These are just models. They're not actually scientifically super correct. So we draw a circle around this, circle around this. So those are bonds. And with this oxygen, oxygen wants to form 2 bonds, right? And carbon still wants to form 2 more bonds after forming these bonds with hydrogen. So that's exactly what it's going to do. It's going to form a double bond, which this right here is kind of ugly, so we can redraw it. We have hydrogen, hydrogen, oxygen. Boom. So that's a double bond. Double bonds are naturally a bit stronger than single bonds. So here, let's try a triple bond. So we have carbon and carbon. 1, 2, 3, 4. 1, 2, 3, 4. And we're going to have a hydrogen on both carbons. So these form a bond. These form a bond. And then all these leftovers are going to bond between the carbons. Wow. And so then you get carbon, carbon, triple bond for 1 hydrogen. Nice. And so down here, it asks us lone pairs or non-bonding pairs. Draw water and carbon dioxide. Show the partial negative regions of these molecules. So this is asking us to do a little bit with polarity. And polarity depends on the shape of the molecules. So if you look at some of these other molecules here, if you look at a chart of the different molecular geometries, you can sort of understand how some of these central atoms work. So like in the single solid line, if you look at the carbon here, it has 1, 2, 3, 4 areas of electron density around it, which are just bonds or lone pairs. So this is going to form tetrahedral. And for the oxygen, it's going to 1, 2, 3, 4 areas. So it's also going to be tetrahedral. If you look down here at this carbon, you have 1, 2, 3 areas around it. So this is going to form a trigonal planar structure. If you look at the triple bond carbons, these only have 2 areas around it. So they're going to spread out 180 degrees, and that's going to be linear. So whenever we're looking at water, we're actually going to put the oxygen in the middle. So we have oxygen, and 1, 2, 3, 4, 5, 6. We have hydrogen, which is 1, hydrogen, which is 1. We're going to draw the bonds in between these. And so shape is very important with water because oxygen has 1, 2, 3, 4 areas of electron density. So it has this tetrahedral structure. But since you have these lone pairs up here, these are sort of invisible whenever you're looking at the molecular shape. So instead of having a tetrahedral structure, water is actually bent. So you have an oxygen with these hydrogens bent down. It's not linear at all. And since oxygen is super electronegative, it's going to hog all of the electrons. So the electrons are going to move towards the oxygen, which means that the oxygen side is going to have a partial negative charge, and the hydrogen side is going to have a partial positive charge, just like that. So water is like tiny little magnets. And if you look at the website, you'll be able to see a couple of the things that result because of that. So in contrast, we look at carbon dioxide, oxygen, oxygen. So carbon has 1, 2, 3, 4. Oxygen has 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. And remember, carbon wants to form 4 bonds. Oxygen wants to form 2 bonds. So that's what it's going to do. Form a bond, double bond, bond, double bond. So you get carbon dioxide. And so with carbon, you have 2 areas of electron density around it. So it's going to spread out 180, and you have a linear molecule. So even though that these oxygens are pulling on the electrons, it's going to be an even tug of war. So there is no partial positive or negative charge because the oxygens are pulling equally at carbon. If this was bent, then the oxygens would be pulling in one direction, and therefore it would be polar, but it's not. Vice versa for water. If this wasn't bent, then the oxygen would be pulling equally in equal and opposite directions, so it would cancel out and be nonpolar. But that's not the case. Ultimately, water is bent, and it's polar. Carbon dioxide is not bent, so it's non-polar. This will be very important as you go on, so make sure that you understand it now.